what you're doing on your network. So the devices that you're supporting, the applications that you're using, the business processes that you're relying on. Okay, so the context of how you're using your network has a huge impact on how we design our networks to properly support that context and create the best possible outcomes. So, when and if something goes wrong during the lifespan of your network, so 3, 4, 5 years typically, it's usually because that relationship between the context of how we're using our network and the infrastructure that was designed to support that context has been ignored or forgotten. So, for today's video, we're going to take a look at that relationship between context and our infrastructure and specifically look at two common consequences of failing to plan for that relationship properly. Okay, so if you're ready, let's get started. Okay, so first, we're going to talk about what's called sticky client or sticky AP. Okay, this is where your client device or your end user device, so tablet, laptop, smartphone, RF scanner, what have you, is trying to associate or connect to the wrong or suboptimal access point in the area. Recently, I was able to hop on a quick call with our director of engineering here at Secure Edge, Eric Portillo, to help explain this type of problem a little bit further.
The most common one is that you have too many APs that are neighboring each other, and they're all on high from a power level standpoint, and so the device doesn't know which one to connect to. Right, you're seeing something that's so far away, but it shows such a strong signal that it's trying to connect to it when there's another one 5 feet from you. Right, so that's the most common one, and that comes from a design standpoint, providing the right channel and power plan and the right dispersion and placement of the APs so that you don't have a sticky AP or sticky client connectivity issue in the future.
Okay, so based off of our conversation with Eric, what we're dealing here in general is understanding how to properly set the power level on your access points. Okay, we don't want it to be set too high where we're introducing a number of problems, in this case, sticky client, sticky AP, but we also don't want to set it too low that we're driving in an increased number of access points that we need to cover our space. Okay, let's switch gears a little bit and let's talk about channels. If you're unfamiliar with channels and channel assignments, you can find more information in a recent blog post of ours that I'll link down in the description below. Okay, the basic principle here is that we use two different spectrums, 2.4 gigahertz and the 5 gigahertz spectrum, to design our networks. And they each have a certain allotment of channels that we can use when designing our network. Okay, but what most people might not know is that we also have to take into account the channels that our client devices or end user devices can also support. Okay, and if we don't do this, there are drastic consequences to it. So to help explain this a little bit further, I hopped on another call, this time with our VP of Engineering, Michael McNamee, to help break down what we're dealing with here.
So not all devices support all 25 channels like in the 5 gigahertz range. You might have this one that does, all 9. This one might do 16. This one might do, all 25. And then when you look at the matrix, the common channels are this, and this. It might only be 12 channels out of all 3 of those devices that are commonly supported. So I would never want to use a channel in the architecture and the config that one of the devices doesn't support, because if that device goes into that area where that AP is using a channel that it doesn't support, it won't see Wi-Fi.
It's basically dead.
Basically dead. It's blind to it. And so you'll see customers contact us saying that they're having problems, right? When we go in and we do this matrix and we look at all the capabilities, okay, your devices, your least capable device is only transmitting at 28 milliwatt, and your APs are set at 100 milliwatt.
Right.
So right there we see an issue. And these devices don't do channel bonding, and you set all your channels to 80, your APs to 80 megahertz. So you're wasting 3 channels on every AP. Oh, and by the way, your devices only commonly support these 11 channels, but you're using 16. So there's instances where 5 channels are distributed throughout your facility, where your AP will walk into, or your user will walk into the area with a device
Right.
that doesn't see that channel and will drop off the Wi-Fi, and that'll spur a ticket because, they're saying that there's no Wi-Fi in that area. Well, to that device, there isn't.
Wow.
Okay, so those are two common problems that we see. One dealing with access point power levels, one dealing with channel assignments, but this time more in the context of knowing what channels to use based on the client devices and the channels they can support. Okay, so here are a couple best practices that you can follow. First and foremost, the most important rule to follow is that you want to design and set your configuration to the least capable device that you're trying to support. Okay, typically you're not dealing with one specific type of device, be it a laptop or smartphone, what have you. It's usually a variety of devices. And so the way to accommodate everything is to design to that least capable, because we know if we do that, our system will be able to support and achieve optimal performance for anything more capable than that least capable device. As a starting point, if you're dealing with mobile devices, so smartphones, tablets, we know from experience that you're going to want to start at around 25% power on your access point, or somewhere between 20 and 30 milliwatts. Okay, if you're supporting laptops specifically, typically we will start at 50% power on our access points, or around 50 milliwatts. So an RF signal, it gradually degrades. It's not like a cliff, kind of like an HD signal, where once you hit the threshold, it just drops off. An RF signal will gradually degrade in performance. And so we have a little bit of variance there, or a little bit of play, right? Where we know we're not going to set it too low and it's not going to be too high. We're going to set it somewhere in that range. Typically for a smartphone, for example, maybe a 25 milliwatt range, even 30 milliwatts, because we know even if that 20 milliwatt device is on the edge of a 25 milliwatt coverage cell, that the performance will be okay. If we were setting it to 50 milliwatts, that 20 milliwatt device would have no performance on the edge of that 50 milliwatt access point coverage zone. Ultimately, it's about understanding and knowing the capabilities of the devices that you're trying to support on your network.
Okay, so what do we mean when we say know your devices? Okay, it basically comes down to 8 different categories. Okay, number 1, device type. All right, so we need to understand, is it a laptop? Is it a scanner, a printer, a tablet? Is it an RF scanner? What type of device are we dealing with? Number 2, make and model. Okay, so is it an iPhone 11? Is it an iPhone 12? Is it a 12 Pro Max? Okay, the specific make and model will have a difference in terms of its capabilities. Number 3, chipset. Okay, what type of chipset is that device using? Okay, is it Intel? Is it an A14 Bionic? Is it a Snapdragon? What type of chipset is in that device? Okay, number 4, OS or operating system and the platform. Okay, so this has the least impact on the RF design, but it can come in handy in terms of a resource when documenting any type of or understanding any type of known issue, right? It can be a resource tool. All right, so in this case, is it running iOS? Is it Windows, right? So is it Apple? Is it Microsoft, etc.? All right, number 5. This is a very important category when it comes to your RF design and your configuration. So 802.11 radio support. Okay, so what standard does the radio support? Okay, is it 802.11a, b, g, n, right? Is it just b and g? Is it b, g, and n? Is it AC? Can it support AX, right? So understanding the 802.11 standard for your devices will have a large impact on your design and configuration. Okay, so starting in the 2.4 gigahertz spectrum, what channels can that device support? Typically, we'll find most can support 1, 6, and 11, but you just need to make sure what channels specifically that device can support in the 2.4 gigahertz spectrum. Okay, 7, just like number 6, but now in the 5 gigahertz spectrum. Okay, what channels can that device support? Okay, is it 36 through 165, right? Is it 36 through 64 and then 100 through 144, right? Is it 36 to 140 and then 149 to 165? Is it not supported at all? Or is there no documentation on that? Right? So it's really important to understand, as we spoke with Michael earlier in the video, about understanding the different channels that are supported by that device. And finally, number 8, transmit power. Okay, is the transmit signal 100 milliwatts, 50 milliwatts, 20 milliwatts? How strong of a signal can that device transmit? And as a bonus, finding any supporting documentation. Okay, so any specific data sheets or user guides, right, that will support the details that you're finding in each category here, that will help you when you're planning your network to support these devices.
Okay, if you understand those capabilities, it will help drive the design and the configuration of your network so that everything comes together just right. Another best practice to follow is to not rely on some of the features that are highly touted by marketing from some of the hardware manufacturers around being able to just take it out of the box, put it on the ceiling, turn it up, and you're good to go, right? Things that auto configure or configure themselves, it's not there to do what a network engineer or a proper design can do. Okay, it's not going to overcome the deficiencies in your system at this level. And finally, if you need some help, if this is out of your wheelhouse or you just don't have the resources or time, please find a service provider that has the experience, that has the certifications in these products to help you out and properly design and configure your network for how you're using it. Okay, so that's gonna do it for me today. Thank you again for stopping by and watching our video. We hope you enjoyed it. More importantly, we hope you got something out of it. We have a lot more coming your way, so stay tuned and we'll see you next time.